being tracked, and when we initialize, we want those all to go to 0. So that's like like so, like so, and like so. Yeah, looks good. Probably want to just call reset state when we initialize, because that doesn't make any strange memory things. Wait, can I do this? And if this were C, you could do this. C++, but I'm not sure about Objective-C. We'll find out soon enough. I think you can do that. Yeah, so now we have everything starting off at 0. Okay. But the thing is, we don't want that B sample to start off at 0. Yeah, we want it actually to be a little bit ooh, that is tricky, isn't it? That initial case is something special because you only have one window at that point, and after that you will have more than one. If you're stretching it only a little bit, maybe yeah, I'm not sure. Okay, but let's get that first window going, and I think I'll remember how to implement this. Alright, so another thing we will need is this kind of handing window. For now, we could hack it and just say it's not, it's just a vertical line, and that's a pretty nasty way to do it, you know. And later we can create a cache table, but we will have to define here the window size and samples, and we can call that just window size. Yeah, stretch window size. We'll call it, you know, doesn't have to be so big. We can just say 1024 for now. That's totally arbitrary, or 512 even. Oops. Yeah, let's just try it with 512. And for now, we're going to do exact half. Yeah, like this. Well, I mean like this. We're always going to have two windows active. So when one starts off, finishes, the next one starts up. Like so. Now it's yellow for some reason. Yeah, and so on. And that will make it a little easier for now. If you want to edit it, yeah, it'll be a little tricky, but not as hard as doing it from scratch. Alright, so how can we go about doing that? So this is going to be, we need these samples to start at 0 and eventually turn into an addition, because we're doing an overlap add. So how can we do that? it's going to be something like this, where we take the index buffer and we do some kind of magical multiplication. So m delay sample multiplied by 2. Yeah, this is right. And we don't, so that's not m window a sample multiplied by 2. Yeah. And it doesn't even matter that this is going to be a double or a float. And the same for this part, right? These can stay the same essentially. You just need to add the +1 here and the +1 here. And we don't need this guy. Looks like we were multiplying by 0.5 because we were doing that echo effect where we would add on to the original buffer onto the input. We're not doing that anymore, so we don't have to be all nice like that. In fact, this will be softer in general. Okay, so this looks pretty good. This doesn't have our envelope, so that's what I want to do now. We'll just have we can have a static C function to do the envelope. So that'll be a double, and we'll just say, or a float, yeah, double. We'll just say panning window, no, panning index, panning lookup. How's that? Panning table. It's a window envelope table. This sounds like a useful function that might be able to get reused in other places. So what we want to do here is compute or look up the value of a panning window or other window at the index. So there's going to be one input parameter, and that'll be in index. And you can even do the static inline. No, you can't. This will be too messy. If it's lookup, you don't want to do that. Wait, you might want to do that. Yeah, well, we'll worry about it later. So, for window length star k, and this is just a helper function, so it uses this should I put window size in there? Yeah, so a linear window, which is just a vertical upside down V, is the easiest thing to do besides the rectangle window, which is just positive ones. So to do that, we just do return index divided by k window stretch size. So we want to return value from 1. Returns value from 0 to 1.0. Yeah. So this will do that. This assumes that index is less than stretch window size. So this creates a slash that looks like this. We want upside down V, so that first half, this part is not there. So to get that, what we can do is we could use absolute function. That's often how you can get those bouncy V lines. That's probably the best thing to do, to be honest. So what we can do is index minus this is the best solution that's coming to my mind right now. Could be there's tons of other great solutions, but you know, this will do pretty much what we need. So this starts off at a value of negative k window stretch size divided by 2. And then, yeah, the other thing to do, it's actually, because we would have to divide this side by 2 as well, we can just multiply index by 2. Like this. Yeah, and this takes precedence. So then you start off at, oh wait. Yeah, that's right. Because you start off at negative, when this is 0, you start off with this, negative k window stretch size, and that'll evaluate to a, no, that evaluates to negative 1. This is still a linear function, it doesn't have any discontinuity. We want the discontinuity, so here's what you do. This is where you do the f-abs, like that. Is there an integer abs? I don't think there's an abs. No. Geez, I'm kind of embarrassed, but I don't know that. Well, we'll find out. There should be, but I tend to just use it. I only really need to use f-abs, or fabs. Yeah, f-abs. Great, abs. No abs. I think I'm right. I'm sure I've looked up this lots of times when I. Oh, there is an abs. And it's in the same. Okay. Alright, so that's great. We can use abs. Yeah, so this looks like it'll do the trick. So abs times 2 divided by index. How does that look? I think that's what we want. Because, so this starts now at positive 1. In the middle it goes to 0. Because that's when these two will come to equal each other. And then at the end it goes back to 1. So great. We have a upside down V. For now, for testing, for quick testing, upside down V. Wait, no, just use V envelope. Yeah, so now we can use that here in our call. This is how we do it. We just multiply. We say